So problem number 4 in this exam was a pair of clicker questions. You can always go back to the actual lecture recordings, etc., to see the discussion of the answers to these, but let's just work through these rather quickly. So number 1 says you have a situation where you have a box M1 and M2 in contact. In one case, you press on the left side of the pair of boxes with the force F, that's case A. In case B, you press on the right side of the pair of boxes with the force of the same magnitude, in which case is the contact force between the blocks larger. Now remember, there's a contact force between the two blocks. Let me just draw this. So if you're pressing in case A on this side with F, there will be a contact force from block 2 pushing back on that, and a force of equal magnitude, opposite direction, pressing on M2, which is what actually accelerates M2. Okay? But the key to answering this question is really to recognize that the acceleration is the same in either case, or at least the magnitude of the acceleration is the same in either case, because if you consider your system to be M1 plus M2, the acceleration is equal to F over M1 plus M2. Once you've got that, you can look at the block that doesn't have F touching on it, say this one, and say, well, that's acceleration is only due to the contact force between them. Let's call that the normal force. The normal force in this case is equal to M2 times the acceleration. In the case A, that is case A. In case B, the normal force is going to be equal to M1 times A, because in case 2, the only thing accelerating M1 is that normal force and has to have the same acceleration. Since M1 is greater than M2, that tells you that the normal force is bigger in case B. And so the answer is B. Common mistakes included things like saying the contact area matters. So some people focused on this contact area between them. That's actually irrelevant, completely irrelevant. I could have drawn the blocks like this with equal contact areas, and the answers would have been the same. Or I could have said that this block is made of cotton, and this block is made of steel, and the answer still would have been the same. So it's not the contact area between them, it's the masses that matter. And the key to this problem, the thing I was really looking for, is did you indicate that the acceleration is the same in your explanation? Because otherwise, even if you answered B, but you didn't indicate that this was the reason, you may have lost a couple of points. For problem number 2, clicker question number 2, this is the professor standing on the edge of a cliff, throwing one ball up with velocity v0, the other one down with velocity v0, and you're asked which one's going to hit the ground with the greater speed, the one that's thrown up or down, or they both hit the same. The real key to answering this question properly, given what we've covered so far this semester, is the concept that v equals v0 squared plus 2a times delta y. Okay, and since although v0 in case 1 equals negative v0 in case 2, if you throw it down, v0 squared is the same. So one key to answering this question properly and easily was to recognize that this is the equation or concept we'll use, that because it's v squared, it doesn't matter whether you throw it up or down. A, of course, is the same. A and delta y are the same. And v0 squared is the same. So these are the concepts I was looking for to get your final answer of C. They both hit the ground at the same speed. The reason is this. It's not enough, as many people said, well, G's the same for both, so they have to hit the ground at the same speed. Well, that makes no sense if you think about all the possibilities. I could have tossed it off to the side, or I could have tossed it at an angle. Those might all have the same v0. They'd all hit the ground at different speeds. In this case, because the vertical component of the initial velocity would be different in these cases. The vertical component squared, really. It's Also, not good to involve time. So a lot of people start writing down equations like v equals v naught plus at. Now, the equation is correct, but they don't hit the ground at the same speed. And v as a function of time is different for both of the balls in this problem. So you could get into a lot of trouble if you started focusing on time instead of this concept. So that was problem number 4.